Hello and welcome to another session in mathematics. In this session, we'll be looking at probability. But before that, let us take a review of our previous lesson. Welcome back. In the course of today's lesson, we'll define terms in probability and probably take some examples on probability, and then we'll call it a day. So let us start with the definition of terms. In probability, there are terms we need to understand their meanings before we can be able to solve any problem. We'll be hearing words like event. Okay. When an experiment is performed, two or more results or outcomes will be expected to happen, true or false. Each attempt is called a trial, and the outcome of a trial is called an event, and it's usually denoted by capital letter E. So an event is what? An outcome of what? A trial. An outcome of a trial. So when a performance or an experiment, an event must what? Occur. An event must occur, and it's just the outcome of what? A trial. Okay, we have what we call random experiment. In the first one, we talked about experiment. So a random experiment is a repetitive process which may result in any one of the possible outcomes of the experiment. Random experiment is what? A repetitive process. Mark that word. Is a repetitive process which may result in any one of the possible outcomes of the experiment. That's what we mean by what? Random experiment. Random, a repetitive process. Okay, we have the sample space. The sample space of a random experiment is the set containing all the possible outcomes of the experiment. I told us that whenever an experiment is conducted, then we must have what? Outcomes. That is what? Results. We must have outcomes or results. Now there is a set of results that are expected. Now out of this set, there must be what? The real outcome. Now the set that contains all these outcomes or results is what we call what? The sample space. So we said it is all the possible outcomes of a trial in an experiment, and it's usually denoted by capital letter S. It is all the possible what? Outcomes. The possible outcomes of a trial. Okay, so we have that the number of the points in a sample space is represented by n, small letter n, into S, and in an event, E is in what? N of E. That is the number of what? E. Remember, we said that E means what? Event, and X means what? Sample space. So we said that the number of the points in a sample space is represented by what? Na of S, and the number of points in an event is represented by N of what? E. So in case you see these two things. Okay, then we have what we call equally likely events. Equally likely events, two or more events are said to be equally likely to happen if the chance of occurrence of each is the same. If their chance of occurrence is the same, then we say that these two events are what? Equally likely to happen. Okay, so I have an example here. In the throw of a die, we know what die is, what we use in playing Ludo, right? So in the throw of a die has 6 faces, right? 6 faces, which is 1 to 6. He said there are 6 equally likely outcomes, which include 1, 2, 3, 4, 5, and what? 6. And the chance of each occurring is 1 out of 6. That is 1 over 6. If you throw a die, it's possible 1 will show. It's possible it will be 2. It's possible it will be 3. It's possible it will be 4, 5, or 6. So the probability of obtaining a 3 is just 1 out of what? 6. Do you understand? That's how we got what? 1 over 6. The possibility of obtaining 1 is just 1 over 6. The probability of obtaining a 6 is 1 over 6. So that is why we say that they are what? equally likely events. So it's either this happens or this happens. They all have the same chance of occurrence. Then we have example number 2. From a pack of 52 cards, the chance of picking any of the cards at random is 1/52. Assuming we have 52 cards written star, block, cross, circle, and all that, and then a card is picked at random, it's possible it will be circle, and the probability of picking one card from a set of 52 is 1/52. Okay, let us then define the word probability. Let us then define the word probability. What do we mean by the word probability? Probability is the measure of chances of occurrence. Okay, now the probability of an event is the chance of its occurrence. That is to say that the likelihood of the event happening with respect to what? The sample space. So probability of E is equal to number of elements in E all over number of total elements in X. Remember, E is our what? Event. I told us that. And our S is what? Our sample space. Remember? Okay. So the general formula for probability is P of E equals N of E all over N of X, where E here is number of events, X here is number of what? Sample space. So this is the general formula we use in solving what? Probability. Okay, so we have what we call experimental probability. Experimental probability. And experimental probability is given as a number of required outcome all over number of possible outcome. Number of required outcome all over number of what? Possible outcome. What do we mean by that? Let's take an example to explain that. A die is rolled 200 times. The outcome obtained are shown below. Find the experimental probability of obtaining A 6, B 2, C 1. Now, that's very simple. Now, here we have the number of chances of occurrence. We have 1 to 6, and then we have their number of what? Outcomes. When a die is thrown 200 times, 1 appeared 25 times, 2 appeared 30 times, 3 appeared 45 times, 4 appeared 28 times, 5 appeared 40 times, and 6 appeared what? 32 times. So to obtain 6, we then have to add the number of what? Outcomes together, and when you add them up, you have 25 plus 30 plus 40 plus 28 plus 40 plus 32. That will give us the total number of 200, since they are thrown what? 200 times. Okay, so we have 200, and then the number of required outcome for obtaining 6 is what? 32. So we have 32 divided by 200. 32 divided by what? 200. That's the number we use in obtaining what? The number of times 6 appeared. So we now divide 32 by 200. What do we have? We have 0.16. So we'll go over to B. 2. That will be equal to 30. 2 appeared 30 times. So 30 over what? 30. That's the probability of 2. Is equal to 30 over 200. And 30 divided by 200 will give us what? We have 0.15. Okay. Then lastly, we have 1. And 1 appeared how many times? 25 times. So we have 1 over 200. Probability of obtaining 1 is equal to 25 over 200. And 25 over 200 will give us what? What's the answer? 0.125. And that's all about the experimental probability. Okay, so one thing about the experimental probability is that it is used to predict the future. It is used to predict the future. It is used to predict the future. Okay, so let's go over to what we call theoretical probability. Theoretical probability. Theoretical probability is the assumed value assigned to the occurrence of an event based on the assumption that each of the elements in the outcome are equally likely to happen. That is by considering the physical nature of the given situation. I told us earlier that that's what we call equally likely events. Okay, so it's either one happens, or two occurs, or three occurs, assuming we throw up a die once. So we either have 1, 2, 3, 4, 5, or 6. So these numbers are likely, are equally likely events, because 1 may show up, 2 may show up, 3 may show up, and so on and so forth. So the theoretical probability now tells us that these events are equally likely to happen. So we shouldn't always use the experimental probability, because sometimes the prediction may be wrong. So that is why we now use what? The theoretical probability. Do you understand? So let us take example in the theoretical probability. It says Tola throws a fair 6-sided die. What is the probability that she throws 1, a 9, B, a 4, C, a number greater than 2, D, an even number, E, 1, 2, either 1, 2, 3, 4, 5, or 6? Solution. Let us start. Okay, we have the sample space, which is X, to be equal to the set of 1, 2, 3, 4, 5, and what? 6. Is that correct? Now, the probability of obtaining a 9. Is there 9 in this bracket, in this set? No. So the probability of obtaining a 9 is what? Is 0, because there is no 9. Is that correct? Fine. Then we'll go over to B. The probability of obtaining what? 4. In this set, is there any 4? We have 4 to appear what? 1. So we have 1 over what? 6. Okay. Then C, the probability of obtaining what? A number greater than 2. Probability of obtaining a number greater than 2. Okay. Numbers that are greater than 2 are 3, 4, 5, and what? 6. 3, 4, 5, and what? 6. And there are how many? There are 4. And I told us that probability is number of E all over number of what? X. So our E now is 4, and our X is what? Is 6. So 2 here will give us 2, 2 here will give us 3. We have 2 over 3. Okay. Then for our D, probability of obtaining what? An even number. We have probability of what? Even number. Okay. What are the even numbers here? Even numbers are those numbers that can be divisible by 2 without a remainder. Those numbers that can be divided by 2 without a remainder. So we have 2, 4, and 6. And that's the set. 2, 4, and 6. Okay. And that will give us what? 3 over 6, which is what? 1 over 2. Right? Okay. Then we'll have E, either 1, 2, 3, 4, 5, or what? Or 6. So we start. Probability of 1, 2, 3, 4, 5, 6, or 6. So probability of obtaining this or this or this or this will give us probability of obtaining 1, which is 1 over 6, plus probability of obtaining 2, 1 over 6, plus probability of obtaining 3, 1 over 6, plus probability of obtaining 4, 1 over 6, plus probability of obtaining 5, 1 over 6, plus probability of obtaining 6, 1 over 6. And the LCM is 6. We have 1 plus 1 into 6 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1, 1, 2, 3, 4, 5, 6. And that will give us what? 6 over 6, which is equal to 1. As simple as that. Example number 2. It said a bag contains 3 red, 5 green, and 7 white balls. If a ball is selected from the bag, what is the probability that the ball is A, green, B, red? Okay, solution. Our sample space is equal to 3 plus 5 plus 7. So our N of X is equal to 3 plus 5 is 8 plus 7, we have 15, right? And the probability of obtaining a red, probability of obtaining green rather, probability of obtaining green is equal to, how many greens do we have? 5. over 15. 5 into itself is 1, 5 here is 3, so we have 1 over 3. Then B, probability of obtaining a red is equal to the number of reds, which is 3, all over 15. And 3 here is 1, 3 here is 5. So we have 1 over 5, and that's all. Okay, thank you for joining us in today's class. We'll stop here, but before we go, kindly provide the answer to the following questions on the screen. Welcome back. So far we've been able to deal with the definition of terms in probability. In our next class, we'll then go over to solvings in probability. So do well to use the lesson note on the platform for better information on what we've just done, and feel free to leave your comment or questions on the comment section. Till we meet again in our next class, stay safe. Bye.